So today we will solve question number 124, binary tree maximum path sum. The question is a very good question to understand how we can traverse the tree and have particular values in our basket. So let's just go ahead. So a path in a binary tree is a sequence of nodes where each pair of adjacent node is a sequence and has an edge connecting them. Which means what is a path basically they are defining. Path will be this edge. So 2 and 1 are the nodes and the edge is connecting them. So this whole thing will be a path. Okay. And the path, sum of a path is the nodes values. Okay. So the sum of path means 2 plus 1. This is the path sum basically. So 2 plus 1 plus 3. This is a whole path sum. And a node can only appear single time in the sequence. And note that path does not need to pass through the root. Okay, so one thing which they are saying is we can only visit one node at one time only, like 2 1 3. We cannot do 2 1 3 1. We cannot do that. That's the one thing. And another thing which they are saying is we don't always need to go to the root. So here root is minus 10. Now we can go like 15 27 also. We don't need that root. Yeah, that's what the overall question is. Let's see how we can solve this. So we will do it in such a manner that the same way we will do in our interviews also in front of interviewer. Okay. So first thing which I can get, which I can understand from the question is like my maximum path value will be keep changing. So first it will be 9, then it will become 9 plus minus 10 maybe, then it will become 9 plus minus 10 by then 20. Then as many nodes I will discover, that many times maybe I will keep changing my maximum value. So obviously I need a global variable for it to keep updating it. Okay, as our maximum max path sum will be keep changing, hence we need a updating variable. Okay, this will be our updating variable. So let's just give it max path sum. So right now we will give it integer dot min value. Okay, that's the one thing. Another thing is I need to recursively traverse this whole tree. So for doing that, we need a helper function. We can use a helper function. So let's just make a helper function. Private helper will pass our tree node to this helper. Okay, let's just name it node better. Node, yeah. So this will be our helper function. So what I will do, as we told, like calling helper function on the root node. So helper, just like root we can write, and yeah, our answer will be stored in max path sum. So returning the final max path sum. So return max path sum. Yeah, that's the okay, that's great. Now what we need to do is base condition. Yeah, so base condition, if my root is equals to, sorry, not root, if the node which I am coming is equals to null, then I have to return what? 0, because there is no path, there is no sum, it will be 0 by default. So yeah, we will return 0. And now we have to make the logic. So what we can do is we can have what, how many numbers of possibilities we have? Possibilities, let's just write possibilities. One possibility is have that we have the maximum path sum on the left value only, so left. Another possibility which we can have, that maximum path sum will be on the right side only, so right. And then next possibility which we can have is the maximum path sum will be root only, so root. Another possibility which we can have is maximum path sum can be left plus root plus right. So L plus R plus root, you can say like that. These are the possibilities. When I say left, I include subtree also of left, like left subtree. and right subtree. Okay, we can say it like this. Okay, so according to it, what we should do is, okay, what we can do is we can create a value called left sum is equals to, we will just call our recursive function on this left part. So here we will get a integer value as our result. Okay, int left sum is equals to helper, and yeah, node dot left. Yeah, and similarly we can do this for int right sum also. Int right sum is equals to helper node dot right. Okay, node dot right. What we are doing here is basically traversing from right and left subtree to get their respective max sum, max path sum value. Okay, yeah. So as I told you, these can be the possibilities. So let's handle our first possibility. So first, so what we will do in this possibility is, let's just create a int temp variable and we will compare these values. So what we have to compare, either our root can be the greatest one, or the node which we visited can be the greatest one, like greatest path sum. Otherwise we can have mat dot max, sorry max our left sum plus node dot val, or our right sum plus node dot val. So in this we are checking whether our node alone is max value, or left plus node slash r plus node is max value. Okay, now the question is why we are storing it separately. Because I told you, so we will take the value of the left and will return it to the root. We will take the value of the right and we will return it to the root. So that's why I am just doing left and node and right node separately here. Okay, if I do this na L plus R plus node here, then I will be not able to have this temp. So using temp, so that we can return particular tree max, particular subtree max path sum. Okay, we cannot return, obviously we cannot return v-shaped travel path with temp. Okay, so yeah, we cannot travel in the v shape, so we cannot hit root right now. We will hit root, but in this part we will hit, like in the recursion call of the root itself we will hit it. And then we have to check whether root is better option, whether something else is better option or not. So one thing which we have to check is left left sum plus r- sorry right sum plus node dot val. So this is the v-shape condition. Left plus right plus val. This is a v-shape condition. Okay. And if either this can be greatest or either one part can be greatest, which will be our temp. So temp, which one will be greater? Anything. So checking whether temp options were better, or left plus right plus root all together is better. So in this condition all together is better. So our answer value will be sum of all three. And what we can do now is update our max path sum. Okay, so max path sum will become now what? Mat dot max of. So either this max path sum which we have previously will be the greatest one, or the current which we discovered. We discovered something here, no? So that one. So just answer comma max path sum. Okay. And yeah, we need to return temp because we need only that particular, sorry, only that particular subtree value, subtree path sum, you can say path sum. Okay, so return temp. Yeah, and yeah, pretty much that's all, and I hope so it should work. Let's just see it whether code has some error or not, and then we will do the dry run also. In dry run I think so you will understand it much better. So okay, we got it. So yeah, let's just do the dry run. So we will do dry run on this one, this example. So okay, what will happen in this example? First, our root will be -10 obviously. So first thing is our helper function is gonna get called on -10. Yeah, -10 it will be get called on. If it will get called on -10, entering this helper function, what we can see is we have left sum and right sum. So now this will trigger what? This will trigger h of 9, which is our left, and h of helper function on 20 also. So this is our right. So it will trigger. So now we have to check h of 9. So what will happen in h of 9? There is no left, so it will return 0. There is no right, so it will return 0. The only option will be the root, which has the value of 9. Okay, these are the three possibilities. So we will just take 9 and it will become the first max value. So in our max value variable, the first value which will be the 9. Okay, then I told you what we have to return is, okay, let's just do what will be the temp here. Temp here will be 9. So at the end we will return this temp only to this 10. Okay, and another recursion which we have to do is on the 20 part. So in the 20 part we can see we have 15, so it will trigger h of 15 and h of 7. Okay, after triggering h of 15 and h of 7, let's just see h of 15. Again, similar to the 9, h of 15 will also return just 15, and h of 7 7 will also only return 7. Both temp value will be also 7. So from here, what we got? 15 temp we got 15 plus 7 temp we got 7. And yeah, by adding root node also, we will have three possibilities, obviously. Just write root here also, which will be 20. So 20, which will be our 42. 42, yeah. So this is what we got. So from h20 and h9, we will get what? We will get these three values: 9, comma 42, comma -10. -10. Now you see the magic. Why I didn't took answer as the return or max path as the return now? Here we cannot have v-shaped value because see 9, then -10 is in the between of path. This 20 and 9 is not connected together. So the only biggest option is 42. So yeah, this our answer keyword will check that only, whether all three together sum is greatest or just the temp is greatest. So you can see here, here when I return 42, the temp was the greatest. So we will just have the answer 42 here. So in this temp also you can see we will have some values, here, and at the end when we will check whether temp is, whether our previous max path sum is greatest or not. So first our 9 become the max path sum, then our 15 will become the max path sum, then our 7 will not become max path sum because 15 is greater than 7, then our 42 will become the max path sum, and finally answer will be max path sum is equals to 42, because this last iteration will not change anything. This will not affect our main answer. So we got our answer like this. So this was the dry run, and I hope so you guys understood how this problem we solved. The only main part of this problem was we cannot have this V shape at the same time. So to eliminate that problem, we did what? We broke the V shape in two parts. We took temp separately and we took answer separately. In answer separately, we are having V shape value so that we can update our max path sum, and in our temp we eliminate this V shape. Instead of V shape we just do this part, sorry, this part, this whole part, or maybe just the center part. Okay, that's the basic logic behind this. And yeah, let's go and see the time complexity and space complexity. So time complexity, you can say you have to visit every single node. So number of nodes will be your number of visits. So O of n will be your time complexity. Okay, and space complexity is this tree height. You can see now 1, 2, 3. So how many times we updated our max? So let's just see. First we updated here 1, then we updated second time here 2, then we updated third time here 3. So the height of the tree will be our space complexity, because we are having this maximum path sum and temp and answer left and right as our static variables. They are gonna get changed number of times. That number of times they will be changed is this this height of the tree. So that will be our space complexity. So O of h you can say. So that's all. Let's just give a look here. So as I told, the helper function visit every node, and so O of n will be our time complexity, and we have static functions, oh sorry, static variables like LR, temp, answer, which will be keep changing. So our worst case space complexity will be O of h, and that's pretty much it. I hope so you understood this question, and let's just submit it and see whether we are passing all test cases or not. Yeah, we are passing. So in your interview, the main part is this logic. This logic. This is the main part. How you are breaking the V-shape constraint. So you get stuck with V shape, na? What I mean by V shape is this V shape, this whole V shape. How to eliminate this thing in recursion? That was the main part. So this was the logic for it. Thank you.